Yes. So Ryan Carlow is the soil and water quality technician for the Lower Thames Valley Conservation Authority based out of Chatham. His primary focus at work is in the Jeanette's Creek subwatershed, gathering data to help researchers quantify the amount of nutrients lost in this area and how that changes with the implementation of best management practices, or BMPs. He has a master's degree from the University of Waterloo with a study on phosphorus removal in agricultural runoff. So welcome, Ryan. Thank you.
Okay, thank you very much. So hello, everyone. Today I'm going to be talking about some of the results seen in our edge of field research sites, looking at phosphorus loss on Brookston clay soils. The primary objectives of this research is to compare the phosphorus losses of no-till continuous cover system to a conservation tillage system on Brookston clay. We also want to test if additional BMPs like no-till and CoverCrops do in fact lower nutrient loss. Collecting this data will also allow us to compare the results in this region to others across the province. And finally, this work, we can provide information to decision makers on how best management practices work on clay soils. The importance of this research is the location of the farms with Brookston clay soils. These soils expand and contract frequently depending upon moisture and temperature conditions, making them more at risk for phosphorus losses during specific times of the year. When cracked, they provide more direct pathways to tile drains, especially with no cover on yield. Previous research has shown that the amount of nutrients lost in loamy soils is different than in soils that are heavy in clay, even if they have similar practices. So what works on loam soils may not be beneficial to clay soils in terms of nutrient loss. Additionally, there's not many studies on edge of field nutrient losses that are looking and comparing a clay soil to another clay soil where practices are different. So there's a need for this type of work in this area. Our research is taking place on 2 farms in the Jeanette's Creek subwatershed. This subwatershed is just south of the city of Chatham and is in the green area on the map on the right. In the second map, you can see the 2 fields we are studying. Each of them is divided 4 plots, and we're collecting samples at 2 of the 4 on each field. Each plot is about 10 acres in size, and all of the tile drains in that 10-acre area coalesce into a single outlet, and that's where we collect our data. The 2 fields are split into Field A and Field B, and they're right across the road of each other. Field A is the conservation till system, and Field B is the no-till continuous cover system. Both fields are using an ideal rotation of corn, soy, wheat. Field A plants cloves after wheat and incorporates a fall tillage. And Field B uses rye after corn and soybeans for a winter cover and a cover crop mix after wheat. In terms of the setup we have for our sampling, these sites have been intensely monitored for about 5 years now, started 2017. So at each of the plots that we're sampling in the 2 fields, we have direct access into the tile drains where we can collect data. We have ISCOs to collect water samples during roof events, and then we also have sensors inside the tile drains to measure the tile flow year-round. Because the sites are so close together, we have a MET station, which gives us accurate rainfall, and that covers both areas. We're also measuring soil moisture and temperature at each of these sites. And all of our measurements are at the 15-minute time scale, so they can integrate together easily, and that helps with our calculations. So in order to collect samples, we target events that occur, runoff events that are likely to occur after rainfall. It usually takes about 15 to 20 millimeters, depending on the season, to get a good runoff event, or it could be a snow melt event as well, depending on conditions. So when the rain or melt is expected, we turn on our ISCOs to sample every 2 to 3 hours. At the event, we're selecting 3 to 5 samples based on hydrograph, so the amount of flow that came out of the tile drain. And these 3 to 5 samples will represent the entire event in terms of phosphorus. We're looking to pick samples on the rising limb, the peak, and receding limb of that event in order to get good representation. So from samples, we filter a portion to freeze, and then we add an unfiltered sample to a bottle with acid in it to make sure that it's shelf stable. These methods preserve the phosphorus levels in the samples so they don't change by the time they're run on the analysis means. And finally, we send the samples to the biogeochemistry lab at the University of Waterloo, and there it's analyzed for dissolved and total phosphorus among some other parameters. So once we get the chemistry results back from the lab, we now have to turn the individual samples into event estimates. So this is a mathematical process, and we're moving from concentrations, which is grams per liter of phosphorus in the water, into an amount based on the field area, which is now in kilograms per hectare. So in the process, we're calculating the phosphorus load for each of the sampled events in a calendar year. For small flow times, that's usually when water is flowing less than 2 liters per second. We're summing all of these periods together and then assigning them a value of DRP and TP based on our samples. We then try to fill in any gaps that we have throughout the year where we use some samples or a probe failed as best we can with information from the other plots, and we use an interpolation method for that. Finally, we sum together all these loads from the event and the base flow, and that leaves us with a good estimate of about how much phosphorus is leaving the field through each individual plot. With that information in mind, I'm going to present some of our findings over the last few years for this project. Here we have yearly rainfall totals in the left graph. And you can see that we have a mix of wet years and dry years, but most often we get about 8 millimeters of rainfall a year. On the right, we're now looking at the amount of tile released from one plot each at the 2 fields. Field A in gray, and that's our conservation till system. And in green, we have field B, and that's the no-till continuous cover system. So for the first 3 years of data, more water is certainly moving through the tile at field A, but in the last 2 years, more water seems to be coming from the tile at field B. It's important to note that we're not getting the exact same runoff values leaving each field, and that's just something we can remember as we move forward with the data here. And just to note, in this presentation, our data for 2021 only includes the period from January to September 30th. So one observation we noticed right off the bat is, like other research, we're seeing runoff is seasonal. On this graph, we have all the runoff events we've sampled in each year, and we've categorized them in non-growing season, October to April, and the growing season from May to September. Because of how close the sites are to each other, most events that happen at field A also happen at field B, which makes our displaying and analysis a bit easier. But occasionally, depending upon conditions, flow can happen at only one of the sites. For all of the years, most of these runoff events are occurring in that fall-winter period of the growing season. So this is why what practices are used during that period is really important. So in this, we're looking at the amount of dissolved reactive phosphorus leaving the 2 fields on a calendar year basis. I've had the crop type growing in each of the field to this and the subsequent graphs for a reference. So right away, you'll notice that the crops were not the same between the 2 fields at all times, and this is due to weather challenges. The growers were not able to follow their ideal crop rotation, and that did likely impact phosphorus loss values, so something to keep in mind. Just comparing the dissolved reactive phosphorus loads, we're not seeing a major difference between the 2 fields, except in 2019, when field B was in corn and using more fertilizer. In general, the fields are losing between 0.1 and 0.5 kilograms per hectare of dissolved reactive phosphorus here. The next graph, we're looking at the amount of total phosphorus leaving the two fields on a calendar year basis. In this graph, it's consistent that field A, the conservation tillage field, is losing more total phosphorus than field B, the no-till field. Overall, the fields are losing between 1 and 2 kilograms per hectare of total phosphorus in a calendar year. And the last parameter we're going to look at is total suspended sediments. And we're just looking at 3 of the most recent years of data here. We have data for some of the other years, but we're still working on processing that. So in the last 3 years, similar to the total phosphorus values, field A is losing more sediments compared to field B. In general, the fields are losing about 400 to 900 kilograms per hectare of suspended sediments. So one of the major finds so far is that these Brookston clay fields are losing more phosphorus on average compared to some other soil types in the province. So previous research that I've done has shown loamy fields tend to lose about 1 kilogram per hectare of total phosphorus in a year, compared to some of the higher values we're seeing here, which is like 1 to 2.5 kilograms per hectare. We can't do a direct comparison. It does show that heavy clay fields are likely losing more phosphorus, even on the most well-manned fields. In general, field B, the no-till continuous cover system, produces less total phosphorus and suspended sediments in its runoff. There is a less clear trend in the difference in the dissolved portion of phosphorus, and this makes sense. The no-till systems are not designed to improve phosphorus losses in the dissolved form. Another observation we're seeing is the benefit of the multi-year research at these sites. Had we collected just 1 or maybe 2 years of data, we might have a different outlook on these systems than what we're looking at right now. So there's certainly some limitations with this research. So consider these results as a work in progress and not at a final statement point yet. Firstly, surface runoff is not included in this presentation. We have installed looms at each field to measure surface runoff, and we did that in 2020 and last year, 2021. We'll have to sort through that data, and we'll be including it in our further updates. Secondly, unforeseen challenges, mostly due to weather, resulted in change to farming practices, making direct year-to-year comparisons difficult because farmers were in different crops during some of the years. Because they were in different crops, it's tough to make any kind of firm conclusions at this point. Finally, and we're looking at this right now, we're trying to combine these results with the land management practices, like fertilizer applications and crop uptake, so we can get a better look at the phosphorus budget for these fields. So the data I presented here, we're just looking at annual losses. We haven't taken into account how much was added, how much was taken out by crops or held in the soil, anything like that. That's more of a phosphorus budget. Here, we're just looking at edge of field tile losses. So I wanted to highlight some of the general trends that we've been seeing over the course of this work. Firstly, is that 1-2 runoff events can really contribute a large amount, maybe 20 to 40% of all the phosphorus losses for a year. So that means that every event throughout the year is not contributing equally to your year-end phosphorus loss. So these larger contributor events are most often happening in the spring and fall with heavy rains, but that varied really year to year. So we pinpoint quite yet an exact month or week or season to most worried about in terms of nutrient loss. We have to be ready throughout all of that non-growing season, because it could happen like 2020, we got all that rain in the fall, or it could be like 2019 when we got all that rain in the spring. It really varies based on year. We don't tend to get a lot of snowmelt driven event in this area, but we did have one last year. And we noticed that it was generally lower in phosphorus than some other events because it was a slow, steady melt. So if we do have a slow, steady snow melt, that may be conditions that we need to be less worried about in the heavy rains in the spring. And finally, the summer storms that we can get, the 30 to 60 millimeter storms, not the crazy 12-inch storms, are generally really quick and they just last a few hours. And compared to those spring and fall events, they're much lower in phosphorus loss as well. So there's next steps for this research. We're going to be working on a longer form report that's more in depth than what I presented here, and it's going to include a total 5-year update. We're producing it with the University of Waterloo right now, and that's going to be out in March. You can check our website for any updates on that. We also have been collecting nitrogen data along with the phosphorus data on these samples, and we'd like to investigate that at a future date. We're participating in the on-farm project as well, which will allow us to look at some of the results we're seeing in this area in context to other edge of field sites at different soil types across the province. We're also continuing to monitor and update our analysis right now. We're working on some of the results from last fall with those heavy rains in October and December, and we just continually keep updating all of our data. So that concludes my presentation. I want to thank all of our funders, supporting groups, and the landowners in Jeanette's Creek for allowing us to do research. And I can take any of your questions. Thanks very much.
Thanks, Ryan. That was great. Anyone have any questions? We have a comment. Victoria says, great presentation. Well done, Ryan. I'll leave it open for questions because I have a few questions myself.
Yes.
Don McCabe.
Thank you. Ryan, appreciate you're in the process of completely analyzing what you've got, and you did cover off the realities. You don't have phosphorus budgets yet to compare just to the losses that you're measuring. But the question I have may require you to think through the budgets or whatever. But the reality is 0.5 of a kilogram, and yes, this is definitely a loss because I paid for that damn phosphorus and I want it to be on my field where it was supposed to do the job it needs to. But what can we do about this issue? Is this something that where's the solutions? Is there a better solution to stop this loss?
I don't think so. From some of the work that I did previously, looking at an edge of field filter to try and cap that last portion of phosphorus loss. And it was a gypsum based filter. And I don't think we're quite yet there on that front either. So I think we need to come to the realization that we're never going to have a zero phosphorus loss system. And that's okay. Fields are going to lose phosphorus. We know that. We're simply come up with a way using different BMPs that can also help in other ways. It doesn't have to be just phosphorus loss, but that combination would make your system better overall. And one of those ways would be a reduction in phosphorus loss. But I don't think we're ever going to get to a point where we have zero amounts of phosphorus coming out of tile drains. And that's probably a reality. So I think the focus should be on getting everyone to a place where we're controlling our losses as best we can, targeting some of the areas that lose quite a lot of phosphorus and reduce those, instead of trying to make sure everyone gets to zero, because I don't think that's possible.
Thank you. I appreciate your holistic outlook because that's the way I've got to operate too.
Yeah, definitely. Thanks.
Thanks, Don. John Kilborn has a question. In the no-till farm, how was the phosphorus applied?
Side dressing at the time of planting, I think, but I'd have to double check that. You get a report when it comes out in March. We'll have more details on that, the application side.
If you have that link, I'm guessing that link hasn't been created yet, but I was going to say, if you wanted,
Not quite, yeah.
not yet. I guess, yeah, my question kind of echoes what Dawn was saying, like where you guys are doing your edge of field research, it's fairly flat and you're still seeing that phosphorus loss and what are your thoughts for locations that have more slope in terms of what could be done?
Right, that's a good question. I think the interesting thing here is that both of these are the heavy clay soils, and they're both fairly well managed fields. Like we're not talking about, it's a conservation till at the field A site, so it's not someone who's ripping up their entire field every single year, and we're still losing that amount of phosphorus. I think that that comes down more maybe to the soil type and the specific conditions in this area. In terms of someone who has more slope, certainly looking at individual BMPs, like something like a no-till or a conservation till, it's tough to recommend for everyone because the impacts are pretty different. So if you have land that has a lot of slope, you may want to look into something like a mortar strips, grass waterway, improving, taking some land out of production potentially if it's really bad. Something along those lines, and because it may not have as big an impact as it does in other areas, but stuff to say.
Another question I had, more just curiosity, with the phosphorus budget, is that a potential for future research and analysis if you could get the funding?
Yeah, absolutely. I think that's something we want to look at because I like this in that we have some numbers to talk about. It's important that when we're bringing this information to farmers, we don't just say, we're losing this, we're losing this. If we can quantify it a bit, like the 1-2 kilograms per hectare per year, those are numbers that people can actually look at and get in their head. And then it comes a point of 1 to 2 kilograms per hectare is actually not that much. Some farmers may say, oh, I'm only losing that much, then why bother with it? So I think that if we can get a budget together, we can show exactly the percentage of how much going on is actually coming off, and then we can present that as well, and maybe give a bit more holistic look at what's happening on a field.
I guess I have another question.
Yeah.
In your, like, I know you've done a lot of research with Merrin Macrae and you've done a lot of edge of field monitoring, and we're seeing these bigger storms. Do you think it's wiser to be preparing for like the 1 or 2 bigger storms of the year or a larger snowmelt, and then all those smaller events will just get covered in the end?
Yeah.
Or be
Yeah, absolutely. It's something that we've seen pretty consistently for the last couple of years that we've analyzed data for, is that 1 or 2 big events really make all the difference. And it's being prepared for those events, like the fall 2021 October. I think we got 4 rain events in a row in the last 2 weeks of that month. And if you were prepared and you had a cover on because you just came out of weeby, then those fields tended to air a bit better than people that had just harvested or were waiting to harvest and didn't have a chance to have kind of cover on the field. They lost a lot of phosphorus during that time. So yeah, I think it's focusing on the bigger events and being prepared for that, watching your timing. If you see a big event coming, don't apply fertilizer, common sense things like that. Control the bigger events, and a lot of smaller events, when you have 14 in a year, they add up to but individually, it's certainly not that much. So not something to worry about. every single time it rains, you don't need to be worrying about phosphorus.
Thanks.